All right, I'm going to go over two problems today from a recent worksheet, the one from May 6th, May 7th. The first one is number 7. We want to integrate secant, tangent, square root of secant, and with respect to x. We know we're specifically going to do this by u substitution because that's the topic of the week. We're going to first look at, well, what are a couple things to try that aren't going to work. Alright, focusing on this over here, when you're integrating with u substitution with trig, it's relatively common that your u will be what you're taking the trig function of. So in this case here, u would just be x. So just as to try it, to be thorough, if we let u be x, that means du is dx. And when we substitute in, those three x's get replaced with u's. The dx gets replaced with du, and we basically have the exact same expression back again, except instead of x's, it's u's. So for this particular problem, letting u be the thing that you're taking a trig function of doesn't work. Okay, so the next place we're going to go to is, well, what happens if we let u be one of the trig functions themselves? So, for example, we could try to let u be the tangent of x. If u is the tangent of x, du is secant squared dx. Now, when we do the substitution, one thing we might notice is, well, we're going to have to substitute secant to some exponent. Well, we have secant to the first, square root of secant here, so we could combine those together. Secant to the first times secant to the 1/2 would be secant to the 3/2. Maybe that would help us be able to make that substitution. So we could replace that tangent with the u, and here that almost matches this, but not quite. Now we know if the only thing we're off by is a constant, we can definitely make it work. Sometimes these can work with some more advanced either trig identities or some more algebraic manipulation. We are avoiding those for the moment, and that's primarily due to time constraints and the circumstances under which we're learning this. If we're going to do it by u substitution, it's going to fit within just a constant. And it turns out that even with those advanced techniques of some trig identities and or some more algebraic manipulation, that substitution is not going to work. It's simply not going to happen. So we know that letting u be x isn't going to work. We know letting u be tangent isn't going to work. So the only reasonable option left is, well, the other trig function here is secant. Let's see if we let u be secant. Alright, so if we let u be secant of x, du is secant tangent dx. Now, what I did here to make the substitution a little bit clearer is I just rewrote the original thing that we're trying to integrate here, putting the secant in front to make the substitution a little bit clearer of what we have to do. So now when we do this substitution, secant x tangent x dx, that can get replaced with du. And then we're left with the square root of the secant of x. Well, secant of x is just u. So we'll replace that with this by that statement. And now we have something that we definitely know how to integrate. So rewrite the square root of u as u to the 1/2, basic power rule, back substitute, and that gets us to our final answer. All right, the other one we're going to go over from this worksheet is number 8. We want to integrate e to the 5x minus 4 quantity cubed times 15 e to the 5x dx. We know we're going to be trying to do this by use substitution. That's the topic of the week. Going to start off with, well, what's not going to work here? So one thing to try would be, what if we let u be this 15e to the 5x? That makes du 15e to the 5x times 5. The 5 times 15 is 75. And as we know from having done a lot of these problems, usually it's in our best interest to get that over here. So we'll divide through by the 75 to get 1/75 du is equal to e to the 5x dx. All right, now comparing the original to what I wrote here, another thing that we know from doing a lot of these, again, that constant, very often we like over here. So I'm going to take that 15, put it to the outside. Now if I try to do the substitution here, we've got e to the 5x dx, we can replace with 1/75 du. So the du we want here, I'm going to put the 1/75 outside, and we have that 15 from this step right here. So what we're left with is we have to do some kind of substitution that gets this stuff in terms of u. Well, we don't have any e to the 5x's minus 4s, that's for sure. We do have an e to the 5x, so we just have that minus 4 constant, but we'd have to bring this back over here, which would give us a du dx substitution inside of this, and we're just looking at a train wreck. It's not going to work. It's not a good choice to make or let the u be e to the 15 e to the 5x. Okay, what is going to work here is if we let the u be this entire e to the 5x minus 4. Okay, then du is e to the 5x times 5 dx, because when we do the derivative part right here, that minus 4, the derivative of that is just going to be 0. And as we've already mentioned, as we've talked about many times, if that constant isn't lining up perfect with that one, we probably want to bring it over there. Okay, so now the original to here, I brought that 15 outside for reasons we've already discussed. The rest of this, other than that 15, remains the same. All right, now when I do the substitution step, we have e to the 5x dx. We can replace that with 1/5 du. We want the 1/5 out here, the du in there, that 15 is just coming along for the ride. And now that e to the 5x minus 4, we're replacing with u. That is quantity cubed, so that gets us to here. Clean up the outside, and then left with basic integration, power rule, and then back substitute to get the final answer.